Okay, in this video we are going to cover another method to find the particular solution. This method is called the parameter variation. So it is very totally different. So because what we are going to do is propose the particular solution out of the homogeneous solution. So the y1 and the y2, they are solutions of the homogeneous differential equation. So the homogeneous solution usually is written like c1y1 plus c2y2. Okay, now somebody come up with this idea. What if we change these constants by variables? w1 of x, w2 of x. And what if that is actually my particular solution, which is here, right? So very similar to the homogeneous, but instead of being constants, now they are variables. Now, what will be those variables? What will be that w1 of x and w2 of x? So that is something that we are going to calculate here on this one. Now, I'm going to assume that the differential equation is like this. Second derivative, and here the coefficient is 1. Okay, so that is the first assumption. So when we develop the formulas, those formulas are going to work as long as the first coefficient is 1. If it is not 1, then you cannot use the formulas. Okay, so the differential equation is going to be second derivative plus p of x first derivative plus r of x, the function, equal to q of x. Okay, now why we are looking at this method is because when this is equal to, for example, the tangent of x, then the undetermined coefficients doesn't work. Okay, now if you happen to have the natural log of x, then the previous method doesn't work. So that is why we need another method. Okay, so assume in generic that we have q of x, and this is the particular solution because the y1 and the y2, they are solutions of the homogeneous solution of the homogeneous differential equation. Then the first solution, if you replace it here, shall be equal to 0, and the second solution, if you replace it here, which is here, shall be equal to 0. So this is true, so there is no question about it. We happen to have the first and the second solution, which is what we do on the first step. Okay, now to see if this is the particular solution, what we have to do is to replace in the differential equations and see what are the values of w1 of x and w2 of x. So the task in this video is what are the values of w1 of x and what are the values of w2 of x. Formulas to get these two guys. Okay, now I'm going to write very small because the demonstration is long, so I hope we get a space to finish this. Okay, so let's do it. So we have to find the particular solution first derivative. Now because we have a multiplication, then we have to do the derivative, so it's going to be w1 y1 prime. I'm going to avoid the as a function of x, so we know that it is a function of x. So it's the first one times derivative of the second one plus derivative of the second one, derivative of the first one times the second one. So it's going to be w1 prime y1. Okay, so that is only the derivative of this, and then plus derivative of this, w2 y2 prime plus w2 prime y2. Okay, and that's it. Okay, so that's it for the first derivative. Now the second derivative is going to be, because we have a multiplication in each one of them, then we have to do this. w1 y1 double prime, because it already has a derivative, plus w1 prime y1 prime. And this is only the derivative of this, only the first of 4. So be careful on that. Now, derivative of this, w1 prime y1 prime plus w1 double prime y1, because it already has a derivative. Okay, that is only the derivative of this. Now, plus derivative of this, w2 y2 double prime plus w2 prime y2 prime. Okay, and then plus w2 prime y2 prime plus w2 double prime y2. Okay, we can reduce this because as you can see, these and these, they are the same, and these and these, they are the same. Okay, now that we have the second derivative, let's replace in the differential equation. So this is going to be very long. So again, in the second derivative, w1 y1 double prime plus, this is 2 times w1 prime y1 prime plus w1 double prime y1 plus w2 y2 double prime plus 2 times w2 prime y2 prime plus w2 double prime y2. Now this is only here the second derivative plus p of x, the first derivative is this one, w1 y1 prime plus w1 1 prime y1 plus w2 y2 prime plus w2 prime y2, that is p of x. Now plus r of x times the proposed solution, and this is the proposed solution, w1 y1 plus w2 y2, and this shall be equal to q of x. Sorry, I don't have enough space, so that should be equal to q of x. Okay, let's factorize what we can factorize. So what I'm going to do is to factorize w1 here, w1 here, and w1 here. So what happens here? So w1 times y1 double prime from here, and then from here plus p of x y1 prime plus, and from here r of x y1. Okay, so that is the factorization of w1. Now I'm going to factorize w2. So w2 is here, w2 is here, and w2 is here. So I'm going to do plus w2 times y2 second derivative plus p of x y2 prime. Here the p of x multiply each one of them, so don't forget that, and then plus r of x y2, and again the r of x actually multiplies this and this. Okay, so and now let's write the rest. The rest is this part, this and this, and that's already covered. So it's going to be this part plus 2 w1 prime y1 prime plus w1 double prime y1 plus 2 w2 prime y2 prime plus w2 double prime y2, and then plus p of x y1 prime y1. I'm going to factorize this plus w2 prime y2, and this is supposed to be equal to q of x. Again, I didn't have enough space. Okay, now here comes some magic. This is 0 and this is 0. Why they are 0? Well, because they are actually this part of the equations. So that is actually equal to 0. So we know that this is 0, and we know that this is 0. So the only thing left is actually this part. Alright? So what I'm going to do is write like this. I'm going to write only this part. So w1 prime y1 prime plus w1 prime y1 prime plus w1 double prime y1. So I just split these two into parts, well, which was originally here. Okay, plus w2 prime y2 prime plus w2 prime y2 prime, and then plus w2 double prime y2 plus p of x times w1 prime y1 plus w2 prime y2, and that is equal to q of x. Now, next step. So we get rid of this part and we only keep this part. Okay, now I just split this. It was in two. I write it here, the both of them, and here we have here this part. Now, let me give you this. What happens if we have derivative with respect to x of w1 prime y1? What will be the derivative of that? The derivative of this will be w1 prime y1 prime plus w1 double prime y1. Okay? And what if you happen to have the derivative with respect to x of w2 prime y1? Now, pay attention that this already has the derivative, right? So because it has the derivative, it's going to be this times the derivative of this, w2 prime y1 prime, plus this times the derivative of this, because it already has a derivative, then it's going to be w2 double prime this is the y2 and y2. Okay? Now, this part, it is actually here. Alright, can you see it? w1 prime, y1 prime, w1 double prime, y1, and here, that is actually here. Okay? Can you see it? So we can replace this by this, and we can replace this by only this. So because I will need this space, I'm going to erase it. So w1 prime y1 prime, and this is going to be the derivative with respect to x of w1 prime y1 plus w2 prime y2 prime plus here the derivative with respect to x of w2 prime y2 plus p of x times w1 prime y1 plus w2 prime y2 equal to q of x. Now, let's factorize the derivative with respect to x. So w1 prime y1 prime plus w2 prime y2 prime. I'm going to write first this and this, and then plus derivative with respect to x of this and this. So it's going to be w1 prime y1 plus w2 prime y2 plus p of x w1 prime y1 plus w2 prime y2 equal to q of x. Okay, now pay attention to this. This number and this number, they happen to be the same. Can you see it? They are the same. Now let's do the following assumption. Let's assume that w1 prime y1 plus w2 prime y2 is equal to 0. If that is equal to 0, that means that this will be 0 and this will be 0, if that is true. So the only thing left is this equal to q of x. So what you have is w1 prime y1 prime plus w2 prime y2 prime equal to q of x. Okay, so what we have here is a system of equations where we can calculate w1 prime and w2 prime. Alright, so we have two equations, two variables, and what are those variables? w1 of x and w2 of x. That was the initial variables. What we need to know here is w1 and w2, because y1 and the y2, the homogeneous solutions, we already know them. Okay, so let me remind you how to calculate the Kramer method. So I'm going to write here, and I'm going to erase it later, but when you happen to have a11x plus a12y, a21x plus a22y equal to c1 and c2, the Kramer method says that the method to find x and y is like this. Delta is the determinant of y of the coefficients here. A11, A12, A21, A22, and that's it. And then delta x is going to be, you replace C1 and C2 with this coefficient, so it's going to be C1 and C2, and the only thing left is A12 and A22. So it's the same determinant, but the first column you replace it with this. Okay. Now delta y is just equal to the same procedure, but you replace the second column, so it's going to be A11, A21, and then here C1 and C2, and that's it. Now to find the value of x, what you have to do is just delta x divided by delta, and to find the value of y is just delta y over delta, and that's how you calculate the values of x and y. Okay, so we are going to use this principle but apply it to this system of equations. Alright? So what are the unknowns? So what I'm going to do here is to rewrite this system of equations. So y1 w1 prime plus y2 w2 prime equal to 0, and then y1 prime w1 prime plus y2 prime w2 prime equal to q of x. Now pay attention that here you have y1 and the y2, and the second column on the or the next equation you have 1 but the derivative. So here y1 prime and y1 prime, they are the same, and the same for w2, derivative and derivative, but the y's, they have a derivative. So that is the only difference. So what we are going to do is to apply this method. So this is A11, this is A121, this is A12, and this is A22. This is C1 and this is C2, and the W1 of x is going to be x, x, y, and y. So if we apply if we use that, using this is the Kramer method, then the equations will be like this. So we have to calculate delta, and delta will be, delta according to the formulas that I just erased was the coefficients, the determinant of the coefficients, and that is y1, y2, y1 prime, y2 prime. Okay, now have you seen this before? Yes, we have seen it before at the beginning of the unit. This is actually the Wronskian, where we check that it is linear independent or linear dependent, where the first row is the functions, second row is the derivatives. So now we don't have a problem because the homogeneous solutions, they are linear independent, so we are sure that this is different than 0. Alright, so we can calculate. Now delta in this case delta 1 is going to be, now using the same procedure, you replace this by the C1 and the C2, so it's going to be 0 q of x y2 prime, and then you calculate delta 2, which is same procedure, you replace this with 0 and q of x, so y1 prime, and then 0 q of x. Alright, now what are the values? So w1 prime, so I'm going to write the w1 prime of x is going to be delta 1 over delta, and w2 prime of x is equal to delta 2 over delta, using the Kramer method. But actually we are not interested on the derivatives. What we really need is w1 of x and w2 of x. So in order to get to eliminate the derivative, so this is the integral respect to x and the integral respect to x, and this is the formulas. This is the formulas you are going to use to find the particular solution using this method. So you don't have to do this every time. So I am providing you here with the formulas. So the set of formulas that are important here is this part. These are the formulas to find W1 of x and W2 of x if you calculate the particular solution in this method. So on the next video we are going to do an example.